Dependency Inversion Principle, or D.I.P, is the most versatile, most powerful principle you could find in a design world. It's very easy to use once you understand the basic, the fundamental idea, and then you apply that in many different levels, either in a module, in a class, or in a React component, or even in backend services. With D.I.P, your design could be very elegant, very extendable, and easy to understand. So today we are going to talk about the D.I.P or Dependency Inversion Principle with React components. And the example we're using is a concurrent example I extracted from a real-world application. And the concurrent example will help you to understand the fundamental of the dependency, what the dependency is, what is a high-level component, what is a low-level component, and how do we inverse the dependency. And then you will see how powerful it is. So without further ado, let's get started. The example we are going to use today is a request type selector component, and we want to make that more reusable as it's already a shared component. So let's talk about the background first. So what is a request type? So let's think about a service desk application. And you have a lot of customers and they have different needs or requests, and they will send the request to you. For example, if you are running an online shop business, and definitely there will be some refund, return items kind of request, and you will need a place for the customer to fill out their request and then send their request to you, and so you can have people to working on it and resolve the request for your customer. Let's say we have such a system for people to select or create request in that system. So because this is the generic request type selector, it has a lot of different type of template, request type template. For example, you can search for HR request type, and you can in a list there will be a leave or onboarding or exit the company, and there are other different types like HR, like business or marketing. You can imagine like there are many different types of requests. So initially there is a component or the request type selector. So user can select a template and then they can use that template in their project. And then once it's published, the customer can fill out a request. So someone can work on it. So initially the components look like this. So there is a search bar, there is a few categories, and there are many templates for the user to pick up, and they can correct the request very quickly. So after a little while, there is another team. They found the request type is very useful and they want to use the same thing. So they want to reuse this screen, let's say, but instead of showing the header like a selected request type, because they are using different scenarios, they don't want to show exactly copy here. So they want to show something like welcome the user, and there's some text here. So beneath the header, all the other like a search category, the tails, select the tail, all the other functionality are exactly the same as the previous one. So now if you are the author of the request type selector component, what would you do in your code? So that's basically the context. Or even once you implemented it and the other day, or someone worked in and they found your component is very useful and they like it, and but they need yet another header. For example, it will be something like this. It's a different style, different text, different wording, but beneath that they have exactly the same thing. So now let's say we have such scenario and we want our software to be flexible enough to support such business request or business change. So I have make a mockup for our demo here. Let's say we have a React component which has a header, and there's a search bar here and a category list. User can select business types, and there will be a few request types for business. And if they selected HR, there will be a different numbers of request type for HR, for example. So this is pretty much a high level mockup. So initially, the request type builder is something like this. It will fetch the templates from remote server, and then it will render a header. It says select a request type and some other text there, and then there will be a selector component which has the search bar, category, and the template list, which is reflecting what we have in this mockup here. So there's the heading, search bar, navigation, and then a few tags or templates. Because we are going to support the other mockup, which is welcome, the username, and then the different description and all the other stuff. So one way to support such request is we can introduce a variable or a flag to tell us in the builder that what exactly the component is used or the header is used. So we passed in a variable called rounded in. So let's say if it's rounded in create a new request type scenario, we will use the old one, which is select a request type and blah blah blah. And if otherwise it's rounded inside something else, like create a new project, we will run it differently with different header, like welcome, username, and blah blah blah. Well, the remaining part of the selector, which means the search bar, category, and the template list are exactly the same. So the header is different. So we will have a switch case or a if-else statement inside the builder to distinguish which header should be used, right? So this is the current implementation, which looks fine. It supports both scenarios for when you create a new request or you create a new project, which is cool. So if we use that component, let's say we want to use the request type builder and we want to run it in a create a new project, create a request type. So you will say in result, it's like select a request type. And if we, instead of running in create a new project request type, we run that create a new project, then you will see it's working as expected. So you welcome username, and then the other text will be shows up, and it has exactly the same thing beneath the header. And then someone reached out and okay, you have a fantastic component and I want to use, but the problem is I don't want to use the welcome user stuff or other header. Instead, I want to use my own header. To support this, we could introduce one more rounded in or extend the rounded in and give it another enum. Let's say creating something else. Let's say something else. And when that one is used, we can add a case here, like a rendered in dot correcting something else, right? And then we can easily define a div and then the header for request type template and the book emoji and then something else beneath. Maybe they have a link in there or even an image. But the point here is we will need to change the request type builder. And let's imagine even further. Because the request template is so popular and it's so functional, it's perfect, and someone else from another team, they want to introduce yet another header for the request type builder. So we will need to do two things. One, extend the rendered in with one more flag, and then increase the case statement here, and then modify whatever they want to change, right? So this is a problem that we want to avoid, because the request type builder is supposed to be a very generic and reusable component. We don't want to be like responsive to whatever they want to change or the consumer want to change. So this is a typical scenario that the D.I.P can help us. So in D.I.P, the components or modules are split into two categories. One is high-level modules and the other is low-level modules. So the low-level module is the generic one that can be used in the high-level modules. So for example, currently the request type builder is used in create a new project, create a new request type, create something else, or even the list can go even longer. So it's used in many different high-level modules, but the high-level module, the low-level module now, the request type builder, is kind of depends or it knows the high-level module exists. And that is a problem that the D.I.P or dependency inversion principle trying to resolve. In the D.I.P, low-level module shouldn't be depend on the high-level modules. The relationship should be reversed or inversed. That means high-level modules, which is a specific ones, should rely on the generic ones. So let's think about the high-level components, which is create a new project, which is a component that use the request type builder, and when you use it, it passes in a flag like to identify itself as a create new project. And in a create new request type component or that screen, it passes in the create new request type when it's using the request type builder. So both are using the request type builder, which is a low-level module. And in the create a new project or create a new request project type, they are all high level. So now the low level is knowing the exist of the high level ones, and that's the relationship we want to reverse. So by looking at the builder now, this header belongs to the new project, create a new project scenario, and this header belongs to the new request type scenario, and there will be more cases here. These header are all specific to the high-level usage, and in a low-level component, we shouldn't rely on that high-level usages. So we need to find a way to reverse this and let the builder or low-level component knows as less as possible of the high-level usage knowledge. So that means we, instead of using the render in and doing the switch keys inside the builder, we should shift this logic outside and let the consumer or high-level component to decide which header they want to use. And that means we will find a way to get rid of this getHeader function. How do we get rid of this? And in React, we can actually pass in the JSX around. That means we could pass the header from the outside world, and then inside the builder, we just use that header, whatever the consumer decided. That means we can extract this one into a component. Let's say const create new project header, for example, and it returns this one, and for the user it's must from the hook count user, like so. So now we have this header, and we will continue to do that. Create new request type, which is another header. which character request type header. It will be this one. Copy, and then we return this thing, right? And we probably will have a create something else header, something else, I don't know, something else. Right, so we now have 3 headers, and then instead of using the rendered in, we can simply use a header and then pass in the header is a React node, and then whatever it passed in, we just use that here, and then we can get rid of this get header and the get current user call. So that means we have these headers in here, and that means we also need to move this header close to where it's actually defined. That means for create the new project, we will move it here, for example, and we will pass in, because we don't have the rendered in here anymore. So header will be create create project header, and for the new request type, we'll be doing the same thing. We'll get rid of this one for now and copy this over to here, and then we use this header to replace the rendered in, which is a header, right? Header equals to the header here. That's the one. So now, if we get rid of the render in, import, and we will clean up the code here. So now the request type builder only has a header as a parameter. Let's have a look at the UI. So it's exactly the same. So if we in the application we render this one, for example, in here, and we will see the header defined as this, and the rest part is exactly the same. So if we look at the request type builder now, it has only one prop, which is a header. So in the future, whenever it's required or someone need to extend it or use the builder, they can decide whatever in the header they want. For example, if let's say I'm a new user, I want to say correct something else, type something else, and then I can do something like this, header, and I can simply define the header like so. I don't know, maybe I do a h1. I can define the style like, transformer, uppercase, for example, uppercase. Let's say this is a header for something else, and then we can use this character something else here, and then the h1 is not enough. Let's say we have a very long description, and let's get rid of the first two, and then you see what it looks like. So now, as you can see, the header can be very complicated. So let's put another thing here. Let's say we have some like a, I don't know, let's say we have a list of items. Let's see, something like this. And on the UI, it's just renders whatever we passed in. Oh, sorry, it should be text transform, uppercase, and we want to make sure the header looks fancy. It's a uppercase, and also we can even do something like a background color to be deep pink. The color of the text will be white, for example. It really depends on the consumer. That's exactly what the DIP is about. So it kind of hand over the control fully to the color or high level components and leave the lower level components much stable, much easy to be shared, to be reused. And if we look at the code again, the main benefit, of course, is it's more stable because we don't have to change responsively on whatever the client is asking for. So all the control logic is shifted to the high level components. And secondly, we get rid of the logic at all. So there is no if else inside the component. It's actually depends on the actual usage. So they define what they want. And so we don't have a if else at all. And also whenever we want to modify or upgrade the builder or low level components, it's much easier because we only hold one copy or one single place to do that. To customize the header is just one possibility. They want to enhance or customize the footer later, which is also fine because we can provide the same mechanism. Let's say we have a footer and you can pass in a exactly the same way, and then you just do the footer as a React node. So then whenever user want to customize it, they just simply pass in the footer. And this is another usage of the DIP, Dependency Inversion Principle. All right, that's what I have for today. I hope you enjoyed. And please let me know if you enjoy or if you like to watch such design principle videos with the concurrent coding examples. Please share your ideas in the comments below. If you want me to demonstrate some other refactoring techniques with your example, leave the comments below as well. Please give the video a like or share with your friends or colleagues or whoever want to learn the design principles or design patterns. And I will see you in the next time. See you.